I am Dr. Sukanya Jayaprakash from Department of Food Technology, Nehru Institute of Technology. Today I am going to discuss about edible coatings and films. This topic comes under the course Food Processing and Preservation. Let's go into the topic. So these are the main course objectives and course outcomes. So what is mean by edible coating? Actually, edible coating is nothing but a thin layer of biopolymers. So which means it consists of proteins or lipids or polysaccharides and resins. It is the main purpose of this is to extend the shelf life of the product. That is the primary purpose. So another advantage of this edible coating is this. It acts as a green technology. That is, it uses the bio waste and also the byproducts of the food industry. So it causes less environmental issues, and it can be eaten because it's edible. So, and also it is biodegradable, not like a plastic. So what makes this edible coating to be innovated? The driving forces behind it are the consumers' demands. These days consumers are demanding very natural products or with some very less chemical additives in it. So this is one of the main reason for innovating these edible coatings. Second main issue is environmental issues. We are facing very much higher environmental issues with respect to single-use plastic films. So in order to replace those, people were trying to find the alternatives. That's why the edible coating comes into picture. And another thing is the retail changes in distribution practices, globalization, and also government strict regulations for having natural edible coatings. So the primary purpose, as I said earlier, it has a barrier properties for moisture, oxygen, carbon monoxides. These kind of gaseous exchanges permeabilities should be lesser. So that is the primary purpose for this edible coating. And the secondary purposes will be, it can act as a functional ingredient. If you coat an edible coating with an ingredients which are having the capability of antimicrobial, antioxidant properties, then that can be an added value to the edible coating, apart from act as a barrier for moisture and gaseous transformations. And also it addresses the physiological ripenings and conditions of the fruits and vegetables during storage and transport. So what is the main difference between coating and films in the sense? In coatings, basically what happens is if the fruit or vegetable will be dipped into the solution, polymer solution, and it gets coated. But in the film, what happens is they will separately form the coating. I mean, they will pour the polymer matrix, add some plasticizers or some additives for improving the mechanical strength of the film, and then they will homogenize the solutions in order to remove any air molecules which gets entrapped in the film. So the final stage will be degassing. Okay, so after degassing, they will pour it in the plate as a thin film. This preformed films can be used as one of the layer in the food packaging materials, or directly can be used as a single layer in the food materials. So that is the difference between film and coating. So these are the main raw materials we were using for edible film preparations. As I said earlier, it is mainly the polymeric, synthetic, not synthetic, it's an edible polymeric, natural polymers. So polysaccharides, starch, cellulose derivatives, protein derivatives and lipid derivatives are the main sources for this edible coating. So this acts as a main raw material. Apart from that, we will be adding some additives and solvents in order to enhance the cross-linkings and the barrier properties and mechanical and the plasticity effect to enhance. We will be adding certain chemical additives, but is in a very, very smaller amount. So based on the mode of action, it is divided into two types. One is active packaging, one another is passive packaging, so or non-active packaging. So as I said earlier, the primary function, if it is met through the edible coating, then it is a non-active one. But apart from the primary function, that is the arresting the physiological actions and moisture barrier, apart from that, if it is adding some value to the food, like what I said, like antimicrobial and antioxidant materials, if we coat along with that, then it will be like improving the quality of the product. So it's adding value to the product. Then it is called as active packaging or active coating in this scenario. Okay, so not only to increase the shelf life of the food, but also to increase the quality of the products, this active coating is used. So there are different methodologies for edible coating. The most common methodology is dipping, brushing, as the name suggests, and spraying and also wrapping up. These are the common methods. Some advanced methods also will be used for edible coating. They are fluidized bed coating and panel methods. So for this section, I am just focusing on the spraying technique. Okay, so the spraying technique, it's basically, as the name suggests, you need to spray the polymer, that is the edible film, using the air pressure nozzles. Okay, so in this picture, I am just showing you some of the orange fruits. Okay, they are actually moving in the conveyor belt. It's continuously moving in the conveyor belt. So a set of nozzles used in the form of droplets. So a sprayer tank will be there which will facilitates the liquid pressures, and the heating jackets will be there that will control the temperatures before passing the liquid as a droplets. And there will be a data logger that will measure the temperature, pH, pressure of both air as well as the liquid which is passing through the nozzles. So the air system and the liquid system is very important in case of spray technology. So this is the basic installation. It's been used in the industrial scale. So initially they will have an air shut valve, and then air regulator will be there, nozzles will be there. So there is a conveyor belt in which the foods will be placed, and from the nozzles this polymer solution will be sprayed down on the food. Okay, so spraying pattern deteriorates with increase in fluid viscosity. So we need to control the viscosity of the liquid. Then only you will be having a very good spraying pattern. And at the same time, if you increase the operating pressure and the fluid temperature, then the spraying pattern will be improved. So these are the two factors we need to consider when you are designing a technique. So, okay, fine. Spray drying, spray coating is very important technology, but the end of the day, the efficiency of the edible coating will be depending on the gas permeation properties. Okay, so how far the efficiency of the edible coating is there, it's always depend on the gas permeation properties, and this can be calculated from this equation. And these are some of the examples I have given. One is the strawberry, another one is the tomato, how you can see the variations with the coating, how it is improved at the room temperatures. So these are the references, and that's the assignment for you to work on. Thank you.